Hello, my name is Daniel Blasco, and I will present an evolutionary approach for generating software models, the case of Kromaia in game software engineering. This work was done along with Jaime Font, Martha Morano, and Carlos Cetina, and we all belong to the SVIT research group from Universidad San Jorge. As an introduction to our work, it should be noted that nowadays there is an increasing interest in game software engineering, shown by recent and past works. This is probably related to the fact that there is a high demand of content, such as DLCs or post-launch upgrades. In this kind of situation, there are fields of study, like requirement traceability, that have been addressed. However, other areas remain unexplored. Past works have focused on the application of model-driven engineering to small or academic case studies. Besides, they were mainly concerned about the issue of portability, that is, the generation of source code from models, which is something about which developers are not that concerned anymore due to the existence of commercial engines like Unreal or Unity. With regard to procedural content generation, past works have dealt with the variation and recombination of properties and parameters. In contrast, our work leverages software models in order to generate video game content. Our work studies a commercial video game which was released in different platforms, and our objective is to generate content in order to accelerate the development process. Kromaia, the video game case study, includes a domain-specific language which can be used in order to define models which can be later translated into its equivalent in terms of source code. In our work, we focused on a certain type of entities, the final bosses. The encoding used by Imogen, our approach to define boss models, takes into account characteristics which are related to spatial organization, behavior, and weapon and weak point equipment. Due to the considerable amount of elements present in a boss model, the use of an evolutionary algorithm is helpful when it comes to the exploration of such a huge search space. The evolutionary algorithm in our approach is guided by a fitness function, which considers both the validity of the boss model generated, as well as a simulated combat between a player agent and the boss created. During our research, we have used different starting populations that could involve or not the bosses that were originally released with the original version of Kromaia. It is worth pointing out that the encoding used by our algorithm includes both properties and elements. Therefore, in addition to the traditional genetic operators, we have used a repair operation in order to keep consistency. During a run of our approach, the models produced are evaluated, taking into consideration validity, optimal health levels after a combat, and the probability of a victory for the player. Bosses studied by our approach could be the ones originally included in Kromaia, others produced completely randomly, all the models generated by our evolutionary algorithm. In the end, all of them are measured using quality indicators from the literature. We have made use of the goal question metric method in order to define the guidelines of the evaluation of our approach. In the end, we are interested in knowing if the quality of the bosses produced by our algorithm is comparable to the quality of those created by the game developers. Additionally, we wanted to determine if the seed strategy used would have an impact on the quality of the content produced. The last aspect studied is the amount of time which is necessary in order to produce bosses with our approach in comparison to the time needed by the game developers. Therefore, the research questions which are related to time would consider wall clock time. In contrast, those research questions related to quality measurement would take into account the most prominent indicators in the literature, which are completion, duration, uncertainty, killer moves, permanence, and lead change. Our approach was evaluated in the context of Kromaia, a video game case study, which is a title that was released for PC and PlayStation 4, both physically and digitally. The production time for the bosses originally included in the game was 10 months. The models for those bosses contain more than 1000 elements, and the developers provided the boss models for both these final bosses and mini-bosses. Mini-bosses don't have the same entity as final bosses, but they share some important characteristics with them. In our research, the production of boss models through random search is considered as a baseline, but, as we said in advance, the measurement of the quality of every model is done through the same quality indicators. Since our approach is not deterministic, we have performed 30 runs for each of the executions, with a time budget of 60 minutes. The boss model population is kept with a maximum size of 100 individuals, and the mutation probability depends on the number of holes. The results obtained in the evaluation of our approach show that Imogen generates final boss models which are comparable in quality to those included in the original release of Kromaia. In fact, the seed strategy has an impact, and those strategies which include bosses from the original game or even mini-bosses show a better result. The time used by our approach to generate 5 final bosses in separate runs is 300 minutes, which is a significantly lower amount of time in comparison to 10 months, which is the time used by the developers. A consideration worth mentioning is that using the original final bosses as the seeds for the starting population could lead to final results which are too similar to those original bosses. For human developers, probably, it would be easier to provide mini-boss models. They are easier to obtain, and they are similar enough to be useful seeds for our approach. We can conclude that our approach is capable of producing content for video games, whole models or final bosses that could be used in a commercial video game. In addition, the results show that the quality of the bosses obtained using our approach is comparable to those bosses originally deployed with the game. In addition, the results show that the seeds used, the final boss models, are going to have an impact if we use them in the starting population for our evolutionary algorithm. Using bosses or mini-bosses from the original game helps our approach obtain better bosses than other methods like the baseline and random search. However, due to the low level of noise present in the boss models, an initial random population could evolve into models with an acceptable level of quality. This was the summary of our work. We hope you have enjoyed it. Thank you very much for your time.